Okay, so today we are looking at 4.2. We're looking at observational study and experiment, and then some of the language of experiments. So we did 12b kind of together, discuss how to do the table. Um, then these are our two goals for this lesson: distinguish between observational study and experiment, and then we're going to explain the concept of confounding and how it limits cause and effect conclusions. So we just introduced the idea of observational study. All you're going to do is sit back and watch. Don't change anything. And then it's good to describe groups of people or situations. The idea here is that you just want to sit back and watch. So one of the things you could do is, if you want to, get the approval first, not just be creepy and watch like kindergartners or grade school kids, you could sit there and watch how they interact with one another. Do they interact better when it's cold? Do they interact better when it's hot? Um, are they able to intermix between grade levels and that type of a thing? Okay. So the experiment one is you have to set up a variable that is changeable, and then you're going to run the experiment many times to see the outcome. One of the things that you have to do is just set up a base trial where nothing's changed. It's just the exact same thing every single time. Okay. Now, what a good example of this is this. So my daughter, when she was in PACE many years ago, they had to do a bottle launch, 2-liter bottle launch. And I was determined to tell her that if you put a spin on it, right, you curve your fins and you put a little tilt to it and you make it spin, that's going to go straighter, and it's just going to go a lot faster, a lot better, and you would win because dads want to win, right? Because we're not, because it was all it was distance. It wasn't how high it goes and if an egg could survive. It was absolute distance, which I loved. And so she was bound and determined to say no. If you just, she was in 6th grade and she was smarter than her dad, but whatever. So what we did is I said, fine, you build yours and I'll build mine, and then we'll go launch it off and see what happens. And so she built hers, and her wings on her rocket were like, all over the place. Nothing was just, anyway, it just drove me crazy and I had to let it go. But mine, I got out the measuring tape, I was measuring out the duct tape, I was doing everything. I got my triangles out and I did the angles exactly the same, every single one of them. I even got the like a soda can, and I curved my cardboard on it, and then I tape it onto it, and then it was nice. I took my cone and I stretched it out and made it really light. I didn't make it light. That was the problem I found out. So I made it long, but with all that duct tape, because as soon as you launch one cardboard, what's going to happen to it? That cardboard is going to hit the nose and just everything's gone. So what I did is I put probably too much duct tape on it, and so it was a little bit heavy, but I was expecting it to be able to go through and spin. Well, it spinned really well, but because of all the weight, it went down a lot faster. Whereas hers, because it was just, we'll just call it pretty unicorn one, and she just launched it and it went so much further and higher than mine. And so she was just looking at me and, I still think I was right. I just needed better materials to build it. So that's an experiment where we're actually coming up with something that we can be measured. Okay. Now, if I wanted to, I could actually go back and experiment with it. And how much do I curve my fins in more? Do I angle it more? That type of thing, and just work with it that way and see what would happen. So our goal is to understand what the treatment does to the response, what the treatment leads us to with the response. So you could almost say the treatment is going to be what kind of variable? Explanatory. And then that's going to lead us into our response variable. Does this have a way to help stop cancer, or does it help lower blood sugar? Is it better than what we do have with less side effects? Does it have more side effects? Does it have all that whole list of may cause intestinal bleeding and everything like that. Okay. So this one, this provides convincing evidence for cause and effect. Oops. That's what I want. Okay, so it's great. So we can go back into there, get rid of our association and say, because of this experiment, we've done it so many times, we are pretty comfortable that this is going to happen. Okay, and then that way we can sit there and say, this is what we know. This medicine will cause you to throw up, but it's going to lower your blood sugar or your cholesterol. And so people who have high cholesterol, maybe it's good for them to throw up a little bit. Just saying. Okay, now, what do you think is going to happen with some of this, though? With all this cause and effect, what can happen? Misinterpretation, okay? Outside variables, good. What else? How about just individual people, right? My genetic makeup is different from your guys's, and so how the medicine affects me is going to be something else. How I think was that? Bias, okay, yep. And then we'll get to that, that placebo effect is kind of a form of bias, but we're going to get to that in a little bit, all right? So what we're talking about is we're talking about confounding, okay? And this occurs pause after this. Associated in such a way that their effect on a response variable cannot be distinguished from each other. So what we talked about a little bit was that observational study has the worst time with confounding, because as you watch people or watch what you're doing, you're not changing anything. What exactly is causing what you're seeing, right? And so there's too many ways to predict what's going on. So that's why confounding has a hard time with observational studies. Your treatments, what we change, what you're going to change. And of course, you can have multiple treatments. Okay, the easiest one to do this, and I'm not bagging on the essential oils, but you could sit there and go like this. You could come up here and say, I have, let's say I've got athlete's foot, right? And grandma says that if you take athlete's foot and you just soak it in Epsom salt every day, you can get rid of it. So I'm going to try that with somebody, right? Grandma, then you've got that weird neighbor that says that if you take, what's the essential oil? Lavender, what's another one? I don't know how to spell that. You know how I do here? This is how math teachers survive spelling. You ready for this? It sounds like it starts with the CAM, and then you just start doing this. That's chamomile. What's the matter, kid? Can't you read that? That's chamomile. Okay, and so then you run this, and basically you have this treatment, and then you have what's called a control, which is basically you just sit back and see if the guy's foot falls off or not, or how bad the feet start to stink. Okay, and so you can change that up and see what's going to happen. All right. Now, our experimental units, I like that one. This is going to be our smallest collection of individuals to which treatments apply. And I'm going to show you this here just a second. Are applied. Okay. I'm going to pause it. Everybody write that down and then we'll go. So what we're going to do is we're doing kind of an experiment. So my concern is the heartworm in dogs, okay? So my population would be what? Dogs, okay? Oops, how do I spell that? Dogs. Now my sample is going to be, I don't know, let's say we're in the vet, okay? And we're going to run it on 50 dogs. So we're just going to sit there like that. We're going to randomly choose 50 dogs, all right? So then this is my sample. That's my 50 dogs. So we're going to have, let's say we have 3 treatments, right? So we're going to have a control, which is SAD, right? We're not going to do anything to help them, but we may give them a fake pill, but we're not going to tell the people that it's a fake pill, all right? And then we're going to give them treatment A. Let's make it 60. That way we can divide it a bit easier. How about that? And then we got treatment B, which is going to be something else. So treatment A could be like an old treatment. Treatment B could be the new treatment, okay? So then 30, oh, let's do the math correct. How about 20, 20, and 20, right? These 20 are my experimental units because I've broken them down into the smallest group that I can, okay? So that's kind of where we got a little confused a couple years ago, is that this, all the dogs possible, my population. My sample is going to be the 60. The experimental units is when I break it down to each individual group, okay? And then of course, if we do humans, they are called subjects. Do I need to write that down for you? I'll just do it real quick. Human beings are subjects. All right, now we need to be careful with the number of treatments. Can you guess why? Okay, could. How about it could lead to what, do you think? Something you just learned today. Exactly. So even with our experiment and we do everything we're supposed to do, if we get too many treatments, that's going to lead us into something that could be leading into confounding. Okay? All right. Now, that was really, really quick. I'm just going to jot down the homework real quick. Now, I will keep going. Now, the reason why I'm giving you so many of these is because then you're able to, because a lot of it's just, what's my experimental units? Is this confounding? Yes or no? And that type of thing. And then Monday, if you have any questions about anything else, we're gonna, this one, that's a scribble. Say, I'm willing to say kind of a work weekend on the homework. Would that be okay with you guys? Okay. You got to go vote.